Thank you. Hi, everyone. We start with like a little question. So how many of you have done something with GenAI? Wow. And how many of you have used RAG to supercharge the GenAI? Great. And how many of you have actually customized or optimized that RAG solution to improve the performance? OK, a couple of hands. All right. So today we are going to share our journey of what we built with AWS Professional Services and with HDI to build a chatbot that basically can answer users' questions in real time. And we are here to share the journey and our learnings and the best practices that come with. So starting with the why.
OK. You guys can hear me? All right. So I know you guys already have a fair share of RAG talks in a couple of years, but let's start with what is actually the vision, or what was the vision behind this project. In HDI, that's like a typical insurance company in Germany that have also a customer agent part that interacts directly with the customer. The main problem was, so the typical problem is customer calls you, have a quick query, hey, am I insured for this thing or that thing? But if you're not an experienced customer agent, you typically can't answer that in, let's say, a quick time. If you are quite experienced, maybe you have some stuff bookmarked, maybe you know something by hand, some tool or something like that. But the problem is you still have to go through a couple of SharePoints, databases to answer your question. What the idea was to bring all of that into one knowledge base so that the agent can interact using a chat interface, using a natural language to just get the right information as fast as possible and can jump through the whole stuff. Because typically, even if you find the document where the idea is or the answer is, you still have to scroll through the whole document, and some documents are over 100 pages long. So how we did that, we came up with, so I can show you guys the top level architecture of that. It's a typical RAG. As you can see, you have an ingesting part. You have the RAG flow that takes in account some feedback loop that we use as like taking into account the negatives and positives that we get from the chat agents, so that we can improve our system. We have some kind of like a static web interface that is at front of the load balancer. And we do use some data from outside that is not, let's say, not the part of the HDI infrastructure. And it is created just in a modular form, just like some Tetris or Lego. So you can just pick and choose some pieces. For example, you don't want to use Bedrock, don't want to use OpenAI, put your SageMaker endpoint in there, and then just be done with that. However, I'm not going to talk about the whole RAG thing here, but we will right now focus on why we chose this part over here. And over to you.
Thank you. So we know that we need a data store, right, to have relevant information. Everything that is available within the company, we store it somewhere. But how should that data be stored? So we need to ensure that the retrieval is super fast, very efficient, and also does not cost too much, right? And therefore, we chose a vector store. So with vector store, we store, along with the data itself, we also store the vector embeddings. I'm sure everyone is aware of embeddings, but in short, just a numerical representation of the data itself, right? So we compared different solutions. We did like a proper comprehensive analysis. And of course, OpenSearch, as you can see, is top class in all of the criteria that we cared about, right? There's just one part, which is the query latency aspect. And this is where we need to optimize, or we need to work and customize according to our use case and how we can improve on this aspect. So a lot of this is dependent on what you need and what your use case requires. So as you see, for us, all of these circled things were very important to us. And OpenSearch overall is a managed and a scalable solution that can store, billions of vectors, and it can support thousands of queries per second. So it was scalable, it was efficient. It basically sounded perfect for us. But this cut off one question of the bigger picture of the RAG, right? So when we think about approaching or starting off with GenAI RAG pipeline, we talk about things, or first things that come into our head, prompt engineering. What kind of prompts should we create? Which LLM are we going to choose? What should be the chunk size? And then we discuss with our colleagues, discuss in the team, and then they come up with more questions. So there's like accuracy, how would we approach the POC, what should be the scope, what should be the metrics that we care about. Then we read about it a bit. And then we come up with even more questions. Like, should we do quantization? Does it make sense? Should we rewrite the query, expand the query a bit to make it more clear? So there's so many things. And it's a bit chaotic, right? So let's organize it a bit.
So how would you typically do that? You will probably create a workflow that would allow you to actually think about the little parts that you see on the slide before. You would have some domain data. You probably don't know where it is. For like us, there was like some SharePoint, some databases that we don't have any access to. So you probably want to have everything in one place at first. Then you do want to have something of a chunking strategy. What do you want to do over there? There are a lot of stuff that you can do over there also. What embedding model is good? If you're using English, that is good. But if you're a typical German company that have a lot of abbreviation that they like, you have a lot of, they love their compound words and then the abbreviation of that. Yeah, that's quite crazy over there. Some embedding models can't even do that. Maybe you want to train your own model in-house and host it somewhere in Sehwag endpoint. Or what vector data store you use, integrated. So for us, that was a good choice that we already have our architecture in AWS. So OpenSearch was quite a good choice. But I'm talking about 2 years ago. That's how we did that. But if you zoom into each aspect there, oh, can you guys see that? No? OK. So you probably want to do like a setup. OK, sorry. Maybe it's just a slide.
You can continue.
Oh, yeah. All right, sorry. So probably you want to have a setup somewhere. Maybe you have an AWS account. Maybe you want to do that locally. Thanks a lot.
Thank you.
But if you want to do that locally, how will you store your data? S3, what about the compliance? Can you store your data on your laptop? I can't. I am just not allowed to do that. So use some secure AWS account. What are the hyperparameters that you want to actually optimize actually at the end? Or what? So to optimize the hyperparameter, you still need some ground truth. How will you get that? You still have to engage some people. So you get your ground truth that if you ask this question, this should be your probable answer to that, or something like that. And it should look into this stuff to answer this question. So the right chunks to find. But then you look into the indexing part. Obviously, you have plethora of stuff that you can do over here. You can do what chunking algorithm you want to use, do something hierarchical, do some custom stuff. Sky is the limit, actually. You can just do anything. What is the chunk size? You use a smaller one, put the whole page in. What about the images and stuff? Or the difficult tables that you have. Maybe there is some marketing table that have multiple rows in there, multiple columns in there. How will you parse that? Or what extra information do you need, actually? The dimensions are, for a vector, it depends on what embedding model you use, the dimension, and then the compression of that, because obviously the more you compress that, the more is the danger that you will lose some insight about your about your chunk. actually. And then lastly, what are the indexing algorithm? OpenSearch does provide you with a couple of them, HNSW, IVF, but it's still a hyperparameter that you still want to optimize. And inside those, there are some parameters that you can further optimize. Next step, on the retrieval part. Do you still want to, after retrieval, do you want to do another step? You want to re-rank. What about doing some overfetching? Maybe you are happy with 5 documents, maybe not. Maybe you want to do some overfetching and then re-rank it. Or you want to go with maybe query expansion, retrieve documents from different edges or something like that. Put some guardrails in there so there's no effing and jeffing coming out of your output or something like that. Or maybe use some, depending on your use case, use some end-short prompting, because that helps in some cases. Last but not least, how will you evaluate that? You can use some Ragas metrics. That's just an open source tool that you can that has different evaluation metrics that you can choose to evaluate your LLM output, or maybe do some customized stuff. However, we also did that as we were developing the MVP. And oops, wait, that's how it looked like. That's just a part of the output from the experiments that we did. You can see like some blue, so some green lines over here that were like a candidate to move into the MVP part, and they were delivering some quite good results actually. I just divided that some in pre-processing part and retrieval part. But as an idea, you can see from the previous slide that you have round about 30,000 combinations, or maybe more than that. But you need a lot of, well, at the start, you do need to invest some time to do some experiments. We did round about 100 experiments before moving to MVP. So we were quite happy with that. And you can see around like 100, you know where you actually are in your experiment setup. To take a deeper look into what we actually tracked, we start tracking like some custom metrics. So we did some document recall, so which documents are important for answering a question, and then what part of the document is actually important. Because sometimes you have a document that has 300 pages, for example, and information for a query is on page 2, but the other is on page 300. So that was part of the parsing and pre-processing part. How would you actually do that? What kind of layout you use? You probably have problems with difficult PDFs that has maybe layouts like two column layout or single column layout. That is quite difficult sometimes to parse. Maybe some stuff do that, maybe something like AWS TextRact that actually do a quite good job to recognize the layout. How would you process the tables? I guess that is one difficult question that I do not have answer to also, but you can do something like that, add additional information to each cell, maybe have a single cell, maybe summarize your cell, or maybe something else that I do not know. Why not? And what about the retrieval? You probably have a lot of chunks. Like we personally haven't gone beyond like 200,000 chunks. I'm not sure about that, but then depends on the size of your chunk also. What information is there? What do you want to do? One thing that definitely we did from the start is doing hybrid search. Well, at that, I think 2 years ago, there was hybrid search. I'm not sure. It was not supported. So we did do a custom hybrid search, and then a custom RRF on top of that. It did work. So, but it's not as good as probably the RRF that is coming in 2.19. But that is how we did that. But if you want to do that today, maybe Akarsha can help you with that.
So here are some hot takes, because as we shared, this was done 1.5 years ago, and it was put in production around about 1 year ago. And we are improving on that, but let's say if we wanted to start from scratch today, these would be few things we would approach differently, right? So first one being, start with creating a baseline, as in use those simple APIs. For example, Amazon Bedrock knowledge bases, right? It gives you everything, all the ingestion part out of the box. So you just have to put your files in S3, and it does all the ingestion for you, right? Behind the scenes, it can still use OpenSearch as an option, but it's good to have a baseline so that you know whatever you're building or optimizing, it's going in the right direction, right? So it's always good to have an easy solution that you have as a POC. Then there is, as Nabeel mentioned, we had a lot of struggle parsing the information, parsing the documents, because we had so much tables, and the layouts were very complex. There's one column, multi-column within the document, and that was really difficult to parse. Similarly, complexities like within a page, if there's a table, and the table continues on the next page, it might not consider it as a single table, and it would not have the information of the headers. So things like this become quite complicated over time, especially when you have a huge chunk of data, right? So something like Amazon Bedrock Data Automation can help you with the initial parsing. So it can convert your PDF files, image files, everything into text. It can even summarize that information for you so that within every chunk that you're creating, you can pass that summary in every chunk so that you know what context we have, what is the topic that we are talking about in every chunk, right? So third one being the flowchart solution. So this is one of the open source solutions that is out there. There's a link to it at the bottom as well. This really helps you speed up the experiments. So we took around about 3 months to do all of these experiments, the 120 experiments or so. And today, once you know what kind of parameters you want to experiment with, you can do these experiments within hours instead of using months, right? Fourth thing, this is a very important learning. Make sure that you create the KPIs from the very beginning. Create the ground truth, align all of different departments like security, businesses, so that everyone knows what are they expecting out of the solution and what should it look like, right? So maybe let's take a bit deeper dive into the 2 of the most important things that we have to consider when we are talking about creating these customizations, right? So, I mean, I'm sure I don't need to explain anything about chunking to you. But essentially, chunking is just, as a rule of thumb, we can say something should be put in one chunk as long as it makes sense for one human, for a human when they read it, right? OK, so there can be different strategies to approach chunking, right? There can be a fixed size chunking. This is computationally the most effective, simplest, and the most straightforward approach. So we are just taking a character size, and we are basically splitting it. We can have some chunk overlap. So to say, for example, 5 characters, so every time, so that we don't lose context between chunks, we do some overlap between, right? Then there can be recursive chunking. So this is essentially splitting the text into more semantically similar parts. And this does it iteratively based on some separators. So the separators can be a page, a paragraph, then maybe a sentence, commas. So these can be custom defined. Then we can also look into the more complex ones. So when you're approaching the chunking, you can use one or more in the same pre-processing, right? One of the ones that we benefit a lot from was the specialized chunking approach, because as I said, we had a lot of tables, a lot of images, a lot of document that was in a particular structure. So we converted that into markdown formats, And then we use that to create the chunks. So to ensure that we don't lose any context, we were taking in the headers, let's say the heading 1, heading 2, or the subheadings, and so everything was taken into account, and all the headers of the tables were also passed into every chunk. So that being said, how do you decide what chunk size to choose? Because the goal here is we have to capture all the essential relevant information that we need to answer the user question. Simple. So how do I ensure that I retrieve all of the relevant information? Simple approach. Take the full document. So take something like more than 2,000 tokens. But then, I mean, for one person, it might work. For a few questions, not a big deal. But when you talk on the enterprise level, it becomes very expensive very fast, because the LLMs charge based on tokens. So that is an issue. And another problem that comes in is the loss in the middle. So when you provide too much context, out of which most of it is going to be irrelevant, it might get confused on what part to retrieve from. Then we go to the other opposite, where we have things like we can just keep a very small chunk. But here we have the issue of having a lot of then chunks, and that makes the search a bit more expensive. And we also have a risk of losing the context. So there is no right answer to this. This is something, once you start experimenting, you try based on your use case. There are some good practices on this, of like what works for most of the, what works for most of the use cases. But it is a lot of experimentation that has to go in to understand what works the best for your use case. We go into the second deep dive.
So let's go into the vector indexing and what we usually did. I think in OpenSearch you have IVF and HNSW. I will not go over IVF, but maybe give like a overview of HNSW and how probably you guys can optimize that if you're using that. So on a higher level, let's start, rather than going into too technical details, maybe like a library analogy over here. So if you want to search something in a library, what is the best way? I think the most efficient way would be that you have anchor points somewhere, and then you just follow those anchor points and then move through the staircases and just go to the last level where probably your document is. That is the most higher level explanation of what HNSW actually does at search time. But there are some parameters that you guys can look at if you are using the algorithm, mainly M. So taking the library analogy, if M are the number of links that are, so number of references that a book has to and other books that are in the neighborhood of that. EF construction is kind of like when you are building the index, it is like the librarian is looking into a list that, okay, this book, the new book is actually more close to this part of the place, and then you put those M references within those lists into that book. And at search time, you have also something like that. So you have kind of a list, and you search through that list, and whichever is in your nearest neighborhood, you take that off of your K most stuff out of that. But how would you like, so as I said, these are the parameters that you can choose, and you definitely can optimize on that. We definitely did that. Typically, you will initialize your vector like this on the left side. You have your parameters, and based on what you want to optimize. If you are thinking about more memory, so optimizing your memory or latency, you probably would go with some smaller values of that. We started with the default. We gave all out on the recall, but we started seeing that we do need some faster recall, because you do not want to wait a lot of time, for a longer time to actually give the right references to the customer agent. So typically, if you want to have a balance of that, go with some middle level stuff. And if you really are like recall junkie, let's say, so definitely go for the higher values. But obviously that comes with the cost. It will take some more time. But after what we optimized, let's give you some key KPIs that we actually measured that are actually from our use case currently. So we are getting like around 26 queries per second on a very good day. On a very bad day, there's none, to be honest. That happens also. Weekends, you don't get anything. We do have a query latency of so it's around 6 milliseconds, but we do some, on top of that, some re-ranking, and then we just already show the agent the documents that are already there. So we optimize the index. We are getting like around 88% recall rate. And we do have a function of feedback, so you can give a positive, negative feedback on your answer. And if there is a negative feedback, you still have a text field where you can write, oh, probably this was not good or something else. And then we use our feedback loop, and then we optimize on the stuff that we already have seen and just do it with our experimentation again. So let's go to probably the outlook of our stuff. We are still looking for continuous improvements. We would like to optimize our cluster also, probably get the feedbacks in, make it more successful. We are already in production since over a year. On one business line, we have already 350 people using that. We scaled a couple of weeks back to another business line, and we are around 800 users that are actually using that. And the future prospect is that we will expand that to around 1,200 users by the end of this year. And obviously, that was the first RAG implementation in the company also. So most of the other business line took this as a blueprint. So they are usually just using the architecture that I show you at the front, putting some stuff here and there, removing some stuff, and still using that. And that will be all from my side. Thanks a lot.
Nice talk. Question time. We have.
Thank you. Really nice talk. You mentioned that there is about 120 experiments, but you talk about there are so many options to choose. There are so many AI algorithms. There are so many parameters, and there is also different chunking search strategies. So intuitively, I think it should grow exponentially. So why there is so little number of experiments?
So, I mean, it's about prioritizing what's more relevant for your use case, right? There's so many things that you can do, but for instance, in here, we already knew that we don't want too smaller chunk size. So we already could remove some of those that intuitively did not make sense for us, right? Anything?
Other than that, obviously, there is, as you said, there are a lot of combinations, or exponentially. And at some point, you do have to move from this idea that you will experiment. Otherwise, you will be in this loop all the time. So we were looking at our recall rate, because obviously it's a RAG. The better your recall is, that's, I think someone here said that, shit in and generated shit out. So that was the whole target, our target. We were like, okay, if we go above 85% recall rate, let's just move into MVP and put the test users in there so they can test that. And then we get the actual feedback that how they would use that, rather than we like predicting the usage of that. And then on those, experiments haven't stopped yet. That was just the start that we showed. Experiments are still going on, but now they are not, let's say, leaps of improvement. They're just like percentage points now, after a long time.
And one more thing to add, sometimes, like for example, embedding models, Cohere, for instance, for English, they only support 5 and 2 vectors, 5 and 2 tokens, sorry, to input. So sometimes they limit it for you. That also happens. Sorry.
Hi, thanks for the talk. I just wanted to ask if you could expand a bit on the evaluation you did. You mentioned RAGAS and LLM as a judge as options. And also particularly whether you were evaluating just at on the whole thing, the output of the RAG system end to end, or whether you were also doing some evaluation and testing on the retrieval stage on its own.
So it was all together. So we were doing end to end also. So just the latency, for example, time to first token, when you actually see the first word coming up in the front end, kind of like that. So, and how long is the answer, for example? That is also what we are doing. But obviously we do the retrieval part also. So for example, this document recall and stuff, that was part of the retrieval accuracy that we were looking at. But then RAGAS, you have a lot of stuff that you can do. So you can do like context precision, context recall and stuff. That is almost the same as that what we customized before. But you can also check your answer also to the ground truth that some guy provided to you, like answer faithfulness and stuff. So you can definitely do that. And I think in the last 2 years, they have putting more improvements on that, on those stuff. Does it answer your question, or there's something more? Okay, maybe
we can talk about it more.
We can talk about that.
One-to-one, yeah.
More questions? Yes, okay.
You said your architecture is a couple of years old, so you're planning to rework on it now?
Sorry, the architecture is...
Hold it, Nabeel.
It's a couple of years old, so do we want to rework it?
Definitely, if there is a part to improve. But it is it almost remained the same since MVP. There are some parts, so this is just like a general outline, but in between that there are like general improvements that we are currently doing, and they are moving on with that. But obviously,
Better options now.
yeah, exactly.
Yeah. So for instance, texttract can now be replaced or maybe updated. And similarly, like within the ingestion lambda, right, we are updating the logic. So how we are parsing it, how we are working on it. So that is being updated, but probably the overall architecture remains the same.
Yeah, I mean, these are just like I said, these are just like Lego pieces. If you don't like this, remove it, just put another thing over there. It will still work. Or not, depending on the accuracy of the stuff.
Any more questions? If not, a round of applause. Nice talk.
Thank you.